Okay, welcome back to school, everybody. I'm in my basement, so we'll see how this goes. We're going to go back and start with Chapter 5. I'm going to redo the lesson that we did the week before spring break, just so that we can, and we're going to go slower. I'm going to just concentrate on the properties of natural logs and logs today, so that in a couple days we'll throw in some derivatives and things with them. But I thought since a lot of you said you had questions, we should just go slow. And so we'll just go back and practice this for a couple days. Properties of natural logs, that would be the ln of x. Remember, you can't have the ln of nothing. Ln has to have something following it. Most of the time it's going to be an x, or you could have a number there that you'd have to plug into your calculator and get, but it has to have something. It's just like a trig function. You can't just have ln. It has to be ln of something. So we'll just say ln of x. The properties of natural log, remember that natural logs and logs are exponents. So all of their properties are based on the properties of exponents. So the first one is the ln of 1 is equal to 0. And that is because this is basically asking what number goes on, or what exponent goes on a number to get me a 1. So you've got some number. What exponent goes on that number to get 1? Well, it doesn't matter what this is. Anything raised to the 0 power is 1. So that's why we've got a 0 here. So anytime you see log or natural log, it's asking what exponent. So what exponent do I put on a number to get 1? And the answer is 0. Because anything raised to the 0 power is 1. The next one is, what if we have a product in here? So I've got the ln of two things being multiplied, whether it's numbers or variables. We want to expand that, and we'll want to expand so that we can find derivatives later. So this is, I'm multiplying here. So I'm multiplying with like bases. What do you do to your exponents then? You add them. So we can expand this to the ln of a plus the ln of b. And you have to give both of these, I don't want to say that you're distributing it, but you're kind of distributing the ln to both of these variables. So we have the ln of a plus the ln of b. And you can, if I had ln of a, b, c, then I can expand that to the ln of a plus the ln of b plus the ln of c. Doesn't matter how many terms you have in there, or variables. You can multiply, you can, have as many as you want, and just keep adding them if they're all multiplied together. Another one would be the ln of a quotient. So if we have quotient of a over b, well, whenever you're dividing exponents, or dividing with like bases that have exponents, what do you do to those exponents? You subtract them. So that means I can expand this into the ln of a, it's always the numerator, minus the ln of the denominator. So some of those problems that we worked on finding the derivative, or whatever week it was, they had more than one variable down here. And anytime you have more than one down here, you've got to put whatever that is. You're subtracting everything in the denominator. So you've got to make sure this is in parentheses if you have more than one variable in the denominator. So if I had the ln of a over bc, that is the same as the ln of a minus, now I have the ln of b plus the ln of c. Because here I'm multiplying these together, so I needed a plus sign because I'm adding using this property up here. Or you could go ahead and distribute this negative sign to both of them and say, well, I'm going to have the ln of a, b is in the denominator, so I'm going to put an ln of b following a minus sign. C is also in the denominator, so I'm going to put an ln of c following a minus sign. So either way, you're going to get to this answer, whether you go this route or you just go straight to here. But whenever you have a fraction, a rational number there, or a rational expression, you always subtract your exponents. when you are multiplying, then you're going to add your exponents. And then we have the last one. I'm going to erase stuff here because I don't have a whole lot of room in my nice little classroom. If we have ln of a raised to the n power. So I have the ln of some number raised to a power. Then we want to expand that as well. That is the same thing as a power to a power. So basically, it's saying what exponent can I put on a to get a to the n? Well, we're just going to, you're multiplying, so you're taking one exponent times the other exponent. So this right here is one exponent itself. This right here is the second exponent. So you're multiplying those two things together. This is where you can kind of, I think a lot of you remember just bringing this out front. And you're bringing that exponent out front because you're multiplying an exponent and an exponent. It's a power to a power. So this gets expanded to a times the ln, or sorry, n times the ln of a. So anytime you have an exponent, just bring it out front. So if I had the ln of x to the third, I can expand that by writing 3 ln of x. And that's it. If I have ln of x to the third, y to the fourth. Okay, here's where we got to be careful. I'm going to have to take care of this multiplication or this product here first. So I'm going to expand by separating them into addition. So I have ln of x to the third plus ln of y to the fourth. And now if I want to keep expanding, these are exponents, these are exponents. So I can bring this one out front. So this will be 3 ln x plus 4 ln y. And this is all we're going to do for a little bit. We're not going to do any calculus. We're just going to practice these properties of natural logs. They can get pretty nasty. Let's do another example. Let's say we have the ln of the square root of x plus 3. So the first thing I'm going to want to do is rewrite this with a 1/2 exponent. So ln of x plus 3, that's all to the 1/2. And then we can use our properties. And the directions for this would just be expand. Okay, that's all we're doing. We're expanding. So I want to make it as long as possible or as big as possible, as many terms as possible, however you want to think of it. Just basically get it to where it's really long. So 1/2 is going to come out to the front because it's an exponent on the whole thing. So 1/2 ln of x plus 3. And there is nothing that we can put here or we can do with that, the x plus 3. So this would just be my answer as it's expanded as far as it can be expanded. Let's see if I can find another one. These all have derivatives in them, but here we go. Let's say I have ln of x times x squared plus 1 squared. And I want to expand this. So we're going to expand. This is a product. I have x times this whole thing. So they have to, that's the only way that you can separate them at the beginning. So this will be ln of x plus the ln of x squared plus 1 squared. I can't do anything else with this. This is in the simplest form that it can be in. But over here, we can do a lot more. Not a lot more, I guess. We can just bring the 2 out front. So this will be ln of x plus 2 ln of x squared plus 1. And that's all we can do. And this was taken from one of the problems that we did last week, or 2 weeks ago, or 3 weeks ago, whatever. So this will help you get into finding the derivatives. So those are the properties. And most of it, whenever we find the derivatives, all we're going to do is expand. We're not going to need to condense. So I'm just going to give you some problems on expanding natural logs today, and that's it. Tomorrow I will give you some notes on the derivatives of natural logs, and then on Thursday I'll probably give you an assignment over that as well. And then on Thursday I'll have a Zoom conference for us. You can ask me questions, and then I'll make your assignment due later that night so that you've got time to ask me questions before you turn in your homework. And I'll probably put in one homework and one quiz grade every week. So ask me questions if you need to, but have fun. See ya.